Hello, welcome back to Proximity Math. I'm going to go over the 2005 Aime Ii number 7. So let x be this complicated fraction, which is 4 over the product of square roots plus 1. Okay, and it's asking us to find x plus 1 to the 48th power, where this is x. Right. So first of all, we'll have to somehow simplify x, which is the denominator. If you try taking conjugates of these, it's not gonna do anything because it's gonna they're gonna appear in the numerator. So instead you can actually use a reverse factorization, which should be obvious if you're on the A level. Right. And that's the 16th root of 5 minus 1, because note 16, 8, we have the 4th root and the 2nd root, which are powers of 2. So if you took the 16th, if you take this conjugate, then in both the numerator and the denominator, sorry. Now these cancel out using difference of squares to a higher power, which is the 8th root now. That's why you don't take the conjugate of this term, because if you take it of this term, now notice what happens. These two cancel out using difference of squares, and you get the 4th root of 5 minus 1. These two cancel out because you want to increase the power, so you go from the 16th root and eventually to the square root. Okay, so using difference of squares, these two become square root of 5 minus 1, because the 4th root of 5 squared is going to be root 5. Okay, and then these two finally simplify to just 5 minus 1, which is 4. And therefore, wait, okay, 4 is the numerator and the denominator, and therefore this is the value of x. Alright, so we have simplified everything successfully, and we have x is equal to this. Alright, now we have to find x plus 1 to the 48th, and luckily x plus 1, I'm gonna add the 1, okay, x plus 1 is going to be the 16th root of 5, which means x plus 1 to the 48th is equal to, so 16th root of 5, that's going to be just 5 to the 1 over 16 to the 48th power, and this cancels out with this to get 3, which is just 125 as our final answer. Alright, I hope this helped you, especially with the reverse factorization using difference of squares, and thanks for watching.